Okay, so we're looking for the discontinuities of the function f of x is equal to x squared minus 3x minus 4 divided by x squared minus x minus 2. Now these are quadratic functions on top and on bottom. You want to find out where each of them is equal to 0. So the easiest way to do that is to factor. Now if you have a linear expression on the bottom, let's say x minus 3, with no x squared term, then you wouldn't have to do factoring. But when you have quadratics, the best thing to do here is to factor the top and the bottom. So if we do that, we can rewrite these on top. The factors of x squared are x and x. The factors of 4 that have a difference of 3 are 4 and 1. Put a minus in front of the bigger number, so a minus in front of the 4. And this negative sign here at the end tells you that your two signs are going to be different. So those are the factors on top. And on the bottom, the factors here of x squared are x and x. The factors of 2 that have a difference of 1 are 2 and 1. It's going to be a negative in front of the bigger number again. And again, they're going to be different. Okay. Now, this will have discontinuities whenever the bottom is equal to 0. Okay, so there are discontinuities when the bottom equals 0. So that means at x equals 2 and at x equals negative 1. So we know that those are going to be the two discontinuities. The question is what kind of discontinuities they are. Well, if you put in negative 1, just check this out. F of negative 1 will be equal to, on top you'll have negative 1 minus 4 is negative 5 times negative 1 plus 1. Well, that's 0. So you're going to get a 0 on top, and on the bottom you're obviously going to get a 0 too. So that is going to give us a whole at x equals negative 1. Now, last year you may have seen that you can also predict the whole just by looking for the common factor. So whenever there's a common factor on top and on bottom, that common factor will give you a whole. Okay. The other thing that you can do here is predict that there's going to be a discontinuity at x equals 2. Okay, because if x is equal to 2, the bottom will become 0. So let's check out f of 2. And f of 2 would give you 2 minus 4 times 2 plus 1 over 2 minus 2 times 2 plus 1. Well, that will be negative 4 times 3 is negative 12 over 2 minus 2 is 0 here. Now in this case, where you have a number on top and 0 on the bottom, that corresponds to a vertical asymptote. Okay, so a vertical asymptote when x is equal to 2. So this graph, x squared minus 3x minus 4 over x squared minus x minus 2, will have two discontinuities. One at negative 1 and another one when x equals 2. The discontinuity at negative 1 will be a removable discontinuity. Okay, so a whole is a removable discontinuity. And a vertical asymptote is an infinite discontinuity. Okay, so those are the two types of discontinuities. If we want to see what the graph looks like, hopefully we can do it here. There's the graph. Okay, so you can see in this case, although I haven't drawn it in, that there would be an asymptote here when x is equal to 2. and we've got the whole here. So this is a removable discontinuity, the whole, and the asymptote is an infinite discontinuity. Okay, so remember, 0 over 0 corresponds to a whole. Some other number, anything that isn't 0, but with a 0 on the bottom, that will be a vertical asymptote. Okay, good luck, thank you.